So if we go to our formula booklet, I'm going to snip this because we're going to use both of them. So we're looking at the length of the arc, so that first one. Okay, so it's just theta times r. Remember, theta needs to be in radians, but it is already. And so arc length ABC is going to be 1.3 multiplied by the radius, which is 3, so that's 3.9. Find the area of the shaded region. Well, obviously this part here is the shaded region, so you've got two options here. You can first of all find this angle theta, so that would be 2 pi minus 1.3. You would then multiply that by, we're using this formula here, by 1/2 multiplied by 3 squared, that's the radius squared. Alternatively, you could find the area of the small part, which is this part here, so you would do 1.3 times 1/2 times 3 squared, and you would subtract that from the area of the full circle, which is pi r squared, so we would have pi times 3 squared minus that value there. So either way, you get the value of, I'm not going to do it on the calculator, you can do it, you know how to do that. So that's, maybe I should show you. So 2 pi minus 1.3 equals, and we're multiplying that by 1/2 multiplied by 3 squared. So it's 22.424. 22.424. So to 3 sig fig, it's 22.4 centimeters squared because it's an area. Alright, next one. So probability distribution of the discrete random variable, find the value of k. Well, these are all our probabilities here. We know the probabilities of events have to add up to give 1. So we know that 0.15 plus k plus 0.1 plus 2k has to equal 1. So that's 3k plus 0.25 equals 1. Oops. 3k equals 0.75. K equals 0.75 divided by 3, which is 0.25. Find the expected value. Okay, so that's where we multiply these values and then add them together. So B is 0 times 0.15 plus 1 times 0.25. Obviously there's follow-through marks from this question. Plus 2 times 0.1 plus 3 times 0.5, because 2k would be 0.5. So that would be 0 plus 0.25 plus 0.2 plus 1.5. Obviously you've got your calculator available for this, and you get 1.95. Okay, question 3. Oh, I thought I wasn't recording then. Okay, question 3. Shows a path diagram, find the equation of the vertical asymptote. So we're looking to see what's this value here. There are different ways of doing this. The best thing to do probably is to sketch it at least on your calculators. So let's put it in. So it's y equals 2 ln x minus 3. 2 ln x minus 3. Okay, isn't it? Okay, so if we graph that, I've got different axes, so let me change my window. Zoom standard. Oh, I didn't press that. What did I do? Zoom 6. Okay, so we can see this is 1, 2, 3, so we can see that that value is x equals 3. And we also know from the nature of the graph that normally that this value has been translated 3 units to the right. Okay, so it would be normally it would be going through this value 1, and that the y-axis is normally our asymptote. But if we've moved 3 units to the right because of this minus 3 here, we know that now the y-axis isn't our asymptote, but x equals 3 is our asymptote. So for this, it's an equation, so it must have the x equals. Some of you had 3, but you didn't want x equals. Find the x-intercept. We know that that happens when the value of y is 0. So we're solving that the function equals 0. I just said that this point normally for a log graph goes through 1. So this one's going to have to be the value of 4. So I know that. If you weren't sure, you can look at your screen on your graph. You can see that this is the value of 4. It says here y is 0, x is 4. Lots of different ways of doing it. You could do calc intercept or calc 0, sorry. I don't know where my cursor is. Oh, there it is. So left bound, right bound, any of those methods will get the value of 0. So the x-intercept is x equals 4. Or the point 40 if you prefer, either are fine. Right, the region enclosed is rotated 360 degrees about the x-axis, the volume of the solid. So remind ourselves that the volume of a revolution is given by this formula. So we're talking about between the line x equals 10 and the x-axis. So we're looking at this point here, so 4. So 10 and 4 are our limits. Okay, and we're using this formula. So we've got v equals pi. Remember the pi can go in front, so it's 10, 4, and then we've got 2 ln x minus 3 all squared. Okay, it's on paper 2, so you're expected to use your calculator for this. Let's see if I can get this done quickly. So, remember math 9. No, let's click out of this. Math 9. So my bottom limit is 4. Upper limit is 10. I'm going to open up a bracket because I need to put the function in squared. So it's 2 ln x minus 3. Close the bracket and square that function. Okay, dx. Okay, so we've got this function in. It's been squared. We're integrating with respect to x between 10 and 4. Press enter. And then you're going to multiply that by pi. So that's 141.537. So that's 142 to 3 significant figures.